Welcome back everyone, Patrick here, moving on to another word problem dealing with quadratic equations. So this is another problem where we're going to be solving for certain integers, and we have two different cases here. So in part A, we have to solve for the two consecutive positive integers where the square of the first decreased by 92 equals 4 times the second. And then in part B, we have to solve for three consecutive positive odd integers where the difference between twice the square of the largest and 5 times the sum of the other two is 162. Okay, so we've done questions like this before. These are maybe a little bit more complex over here, but same sort of process applies. What you want to do is set up expressions for the integers that you're solving. So two consecutive positive integers. So if we have two consecutive integers, we know we could represent them as x and then x plus 1 like that. And then we just have to create an equation here. So two consecutive positive integers where the square of the first, so that's going to be x squared, decreased by 92 is equal to 4 times the second integer, like that. Okay, and then that ends up being the equation that we would be solving here. So to solve this, we would expand this part, then bring everything over. We'll have x squared minus 4x, and then when we bring the 4 over, we'll end up with negative 96, like that, and that's going to equal 0. And then because we're solving for integers, the x, right, x is the lower of the two consecutive integers. X is going to be an integer, so usually these are going to factor smoothly, and this does factor into x minus 12, x plus 8, like that. So we get two solutions, x equals 12 or x equals negative 8, but the negative we would ignore in this case because they're looking for positive integers right here. So the negative 8 won't work out, and so we would end up with 12 and 13. That would be the answer for part A. And then you could check it. If I plug in 12 here for the x, we'll have 12 squared, which is 144, minus 92 would give us what? 52. And then 13 goes here, or 12 goes here for the x, so x plus 1 is 13, right? This second integer times 4 would also give us 52. So the left side is equal to the right side, and it makes sense according to the problem. Now, in part B, notice that we're going to be dealing with three consecutive positive odd integers. And remember, whenever we have consecutive odd or even integers, as we showed in the videos before, you want to represent those with a difference of 2 between them, and there's 3 of them in this case, right? So if we have like 11 here, this would be 13, this would be 15. The difference between them is 2. Same thing if we had 3 consecutive even integers. We would still represent it like this because consecutive even integers, so like 8, 10, 12, they also have a difference of 2 in between them. All right, so this would be it here. And then let's create the statement. So the difference between twice the square of the largest, like that. So if we take the largest of the integers, square it, multiply it by 2, the difference between that and 5 times the sum of the other two, so the other two integers being the x and the x plus 2, we would just sum those up over here. 5 times that sum, the difference between those is 162, right? The difference between these two expressions is 162. And so from here, we just have to expand everything. Simplify x plus 4 times x plus 4. That would simplify to x squared plus 4x plus 16. Or no, sorry, 8x plus 16, like that. And then we'll have minus 5. Let's simplify the bracket first, like that. That's going to be 162. So over here, we'll have 2 squared plus 8, or sorry, keep messing up here, 16x plus 32. Minus 10x minus 10 equals 162, like that. Then let's bring the 162 over, and so what we would end up with, let me keep the original expression written out, 2x squared 16x minus 10x, that would give us positive 6x. Then we got 32 minus 10, which is 22. When we bring the 162 over, 22 minus 162 would give us negative 140, like that. And that's going to equal 0. Let me just make sure that everything, yeah, it seems like we have everything. So now, let's try to solve this. Again, you could solve this with factoring or the quadratic formula. Because we're solving for integers, we should be able to factor smoothly. So I'm going to take out a 2 from this. So we would have x squared plus 3x minus 70, like that. And then that right there is going to equal 0. And then notice that this, two numbers that multiply negative 70 add up to 3 would be positive 10 and minus 7. So we'd end up with 2x plus 10, x minus 7, that's going to equal 0. So notice we get two solutions, x equaling negative 10, x equaling 7. But notice they want to have positive integers. So we would ignore the negative 10. And so it would be 7, 9, and then 11. That would be the set of 3 consecutive positive odd integers that satisfy this statement, right? And then again, we could take these values, plug them in, and then see what we get. So if we take the largest of them, 11, square it, that would be 121, times 2, that would give us 242, minus 5 times the sum of the other two, so 9 times 7 would give us 16, times 5 would give us 80, and notice 242 minus 80 would give us that difference of 162. So these solutions make sense according to the words that were given. All right, so the trickiest part is coming up with this expression here, the initial one, but once you have it, you just expand everything, bring it to one side, and solve. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.